In this video, we're going to develop a strategy to factor trinomials with a leading coefficient of 1. Since we know the process of factoring is the opposite process of multiplying polynomials, let's develop our method for factoring a trinomial with a leading coefficient of 1 by first multiplying two binomials, and then we'll work backwards and develop patterns to develop our method. So let's multiply the binomial x plus 2 by the binomial x plus 3. X times x gives us x squared. So it's important to note that when we multiply the first term by the first term, which is x times x, we get x squared. Now let's multiply x times 3. That gives us 3x. Now multiply 2 times x. That, of course, gives us 2x. And let's multiply 2 times 3 to get 6. Now let's combine our like terms in the middle. 3x and 2x are like terms. So we'll have 3x plus 2x is 5x and plus 6. So when we multiply x plus 2 times x plus 3, we get x squared plus 5x plus 6. So that was the process of multiplying a binomial by another binomial. And the result is a trinomial, 1, 2, 3 terms, with a leading coefficient of 1. So if I were to give you this trinomial with a leading coefficient of 1 and ask you to factor it, or if you want to think about the process of factoring as finding the FOIL, you can. So if I were to give you x squared plus 5x plus 6 and ask you to find the FOIL that created that, well, your response should be x plus 2 times x plus 3. So what are some methods that we can develop, or what are some patterns that we can identify that will help us go from a polynomial of x squared plus 5x plus 6 to its factored form of x plus 2 times x plus 3? The first thing that we need to know is that trinomials are the result of multiplying two binomials. So if I ask you to factor a trinomial, the very first thing we're going to do is create space for two binomials. Now let's turn our attention to the first term in our polynomial, which is 1x squared. To get 1x squared, the 1x squared is the result of multiplying the first term by the first term. So if we want to get a 1x squared, then each of our first terms has to be 1x, or just x. Or in other words, the first term in each binomial will be one factor of the squared variable, or of the given variable in our polynomial. So if the first term in our polynomial is x squared, then the first term in each binomial will be x. If the squared term in our given polynomial is y squared, then each term in the binomial will be y, because y times y gives us y squared, and so on. Now let's look at the third term in our polynomial. The third term is the result of multiplying the second term in each of the binomials. So in other words, the positive 6 is the result of multiplying the 2 times 3. So that means the products of the second term in each binomial must be equal to the third term in the trinomial. In other words, the numbers that I put here and here in my factorization, when those two numbers are multiplied, it must be equal to the third term in the trinomial. In this case, that's a 6. But there's one last piece to this puzzle that we haven't talked about yet. And that's the fact that the two numbers I choose to put here and here in my factorization not only have to multiply to equal the third term in the trinomial, but they also must add to get the coefficient of the x term in the middle. So in other words, these two numbers have to multiply to get 6, but they also have to add to get 5. Because notice, when we simplified our multiplication up here, when we combined our like terms, we had a 3x plus a 2x. So in other words, 2 plus 3 gave me the 5x, but 2 times 3 also gave me the 6. So the sum of the second term in each binomial must be equal to the coefficient of the middle term. And that's how we know that positive 2 and positive 3 are the correct choices for our second term in each of our binomial factors, because 2 times 3 gives us 6, and 2 plus 3 gives us 5. So the correct factorization of x squared plus 5x plus 6 is x plus 2 times x plus 3.